Hello and welcome to this look at an applied calorimetry question, specifically looking at delta newt H. So obviously it says the question looks at neutralization reactions, so you need to think for a second about what that means. First thing I'm going to focus on is the most important piece of information, which is this, what the student actually measures out. So sometimes it's quite useful to visualize what's actually being done before you start sort of trying to tackle the question. So essentially there's two 35 centimeter cube samples, one of KOH and one of H2SO4. So together they'll react to make potassium sulfate and water. Obviously it's your classic alkali plus acid makes a salt plus water reaction. So the thing to do is to work out the number of moles of each individual sample before they're mixed together. So then you can see straight away that you've got 0.084 for the KOH and 0.042 for the H2SO4. You can also work out delta T from the change in temperature, and that's obviously something you can use later on when you do Q equals mc delta T. So like I mentioned, it's a neutralization reaction, so that's going to be looking for the moles of water made when we're calculating delta H later on. So they want you to write the overall equation for the reaction that takes place. So you start off by putting in the basic acid plus alkali gives you salt plus water. So in ionic form, neutralization refers to H plus ions reacting with OH minus ions in aqueous solution in a 1:1 mole ratio to make water. So it's the energy released when 1 mole of water is made from the reaction between an acid and a base. So the calculation of delta newt H must be based on 1 mole of H2O being formed. So in order to balance this, you can split it into its ions, each individual species that's aqueous, and then you can see quite quickly that you need 2 waters and 2 OH minuses. So that means 2 KOH and 2 H2O, so tidying it up gives you something like that. So it tells you that there's 1 mole of KOH and 0.5 mole of H2SO4 being reacted, and you need to calculate the enthalpy change for that. So this is the correct mole ratio according to the equation we just worked out. So that means 1 mole of water will be formed. And the reason I say that is because if you look at the KOH, there's 2 moles of KOH and 2 moles of H2O. So what they've really done is just split it in half. In other words, instead of 2 moles of KOH, you've got 1 mole of KOH. Instead of 1 mole of H2SO4, you've got half a mole of H2SO4. So the specific heat capacity for the solution will be the same as for water, so it will be 4.18 joules per Kelvin per gram, as you can find on the OSR datasheet that you would get with any assessment like this. So we're putting in Q equals mc delta T. The total mass of the solution, if you remember, we did a little visualization of this in a previous slide. That's 2 sets of 35 centimeters cubed. And obviously the density of the mixture is 1 gram per centimeter cubed. So the specific heat capacities are 4.18, and the delta T is the temperature change in Kelvin that we looked at a little bit earlier as well. So 2 lots of 35 give you 70, multiply that by 4.18, and then multiply that by 16.5, giving you 4827.9 joules. So delta newt H will be the value of Q minus Q, that is, because it's an exothermic reaction. We know this because it said that the temperature increased. So minus Q in kilojoules over the number of moles of H2O. So that's minus 4.8279 instead of 4827.9, divided by 0.084, which we worked out earlier on. And then that gives us minus 57.5 kilojoules per mole. So finally, it says to explain why the answer to part 2 is the enthalpy change of neutralization. And it's the energy released when 1 mole of water was made from the neutralization of an acid with an alkali. Then it wants you to work out the percentage uncertainty of the temperature rise. So because the temperature rise involves a starting temperature and a final temperature, you use the thermometer twice. So it's 2 times the absolute uncertainty, which is 0.5 degrees C, divided by the temperature rise that was measured. So that's the difference between the two readings. So we worked out 16.5 earlier, so 2 times 0.5 over 16.5 times 100 gives you 0.06%. Okay, as always, thanks for listening. Hope this has been useful. Until next time, see you soon.